Hey. Hello Dave, this is Reed McBride again. I'm going to send you another video because the last time we talked, when you called me in Seattle, we were having questions in reference to the joints that where the truss will be anchored to the top of the column and the header, and then you follow along, and this is where the truss is anchored to the wood rafters in the roof. And what we're going to do, my neighbor is the photographer and I'll narrate it, and the question that we have now that's holding up the permit is the county says this structure completely must be able to withhold or withstand 140 knot winds. So what came up for you was the joints, and what we're going to do is go outside now and I'm going to point out these joints to you and you'll be able to see them, and then you can sign it off. Okay Dave, what we're going to point out now is the first joint, and this is the steel truss that you see in the blueprint, and this is the truss going to the roof in the house. And the way this is set up is this is 1/8 steel. It's been cut through with a plasma cutter. It is anchored with these 3/8 lag bolts, and they're going all the way through into the rafters. The rafters are 2x6, they're every 24 inches. All Steel Roofing said they want one on every rafter. There's about 26 of these. This is welded, it's a MIG weld. This is 1/8 steel, 1/8, double MIG welded in all positions. They wanted it to sit just below the roof, and when they go to put the metal roof on, they're going to be using a piece of plywood like this. The entire house will be a metal rooftop. It's going to be continuous all the way across. So this is the joint assembly for the truss to the house. We're going to go across to the other side now, and I will show you how this steel truss is going to be anchored to the steel headers.
Yep.
And Dave, here we are on the other side. This is the headers. You can see the columns behind me. They're all 1/8 steel. At the joints, we'll get to that later, but this joint right here is going to be 1/8 angle steel welded, and this will be welded to this structure here. There's two ways to do it. This is welded right here in the front and the back, and then I can burn through this and put bolts through with a plasma cutter, or I can just weld it. So each section every 2 feet will be like that. Okay Dave, now we are out here on top of the headers, and I'll walk you through the metal joint that's out here. This is 1/8 steel, 1/8 steel, 1/8 column steel. In between the two is 1/4 inch steel, and it's welded all the way around, all four sides, and this is burned through. The reason I burned through the top of this steel with a plasma cutter is so I could drop a 1/2 inch bolt. It goes through all the way down to the bottom of the header, and then it comes out the bottom through the plate. And what allows me to put sockets in there like this, and I can torque down the bolts at each joint. And then if you notice, there's an open root here, and this is where I'll come back and MIG weld this all the way around once I have the permit. I can't do it now because it's not authorized. So in each joint you have a 1/2 inch bolt through a 1/2 inch plate. This is what they're concerned about, the 140 knot wind. So Dave, here we are at the base of the through bolt, this 1/2 inch galvanized through bolt that came through the top of the joint in this truss here, comes all the way through. It's bolted. This is welded here, and this 1/4 inch steel plate will be welded all the way around on both sides for each of the 6 columns. So if my terminology is right or wrong, I'm calling this a column, I'm calling this a header, the joint. These metal pieces going across, I'm calling them a truss. I don't know if I'm calling it right. And then the wood that's in the house we call a rafter. So that is what you were asking me about on the phone. The other thing that was concerned about the wind factor out here is the overhang. This overhangs by 1 foot. It's bolted on and welded here. And all steel is going to make a fascia to go all the way across, and that'll be the full length of the patio. And they said go no more than 1 foot. This is on the blueprint, you'll be able to see it. And then the other part coming across where we have the trusses, I was going to weld diagonal braces in between, and they said that is not necessary. They're going to be putting down 1/4-inch plywood, which you see up here. There'll be plywood, and then there'll be the sheet metal roof, and they said their metal screw guns can go through all of this metal, and the strength, the lateral strength, will be in their roof, so we don't have to put truss, but if need be, I can add them in and weld them. They said it's not necessary, so don't do it, so we won't. So the next thing we'll do, we'll come down here, I'll show you the welding equipment real quick, and then I'll show you the other lanais that were destroyed here with wind spouts. Okay, Dave, real quick, I don't know how much you know about welding, but I'm going to just go spend 30 seconds here to show you the welding process for this entire assembly, in case anybody asks you. The process you're most familiar with is when people use stick welds to weld steel and things of that nature. They have a machine where they hold it and it burns down. On these rods it'll say 60,000 or 70. That is the tensile strength per square inch on the weld. So you can weld with stick or you can weld with wire. We are doing a wire welding process. This is what they call flux core arc welding. There is a component inside the wire along with argon gas, and it is certified to 70,000 pounds pressure per square inch on the weld. So this is the procedure for the whole assembly. It's a lot faster and a lot cleaner, and you can do it mostly with steel if it's all the same size. And when you use argon gas instead of powder on rods, you don't have spatter. So this is how you weld it. This is how you cut it. This is called a plasma cutter. It's a laser. It'll go through 3/4-inch thick steel, and here's how we made the joints. We cut them out, and then we made the parts and the clips, and then we cut. That's how you cut through. You can get your bolts in, and you can secure it, and then you can weld it up. So if anybody asks questions about the welding procedure, that's my responsibility, and this will help Henry too. I think Henry at All Steel may want to get into this patio business too, and he'll have to do everything we're doing here. The last question was about the open lake and the landscape here. When hurricanes come through, they build up strength over the lake. That's why they wanted this to be cut off at 1 foot, so the whole roof structure wouldn't come up, so we're set for that. And there's a few lanais here that were destroyed by wind spouts. Everything here you see is aluminum, and it doesn't hold up. This steel structure will hold. We have sinkholes here too. Sun City Center is a landfill, and I have a sinkhole opening up there. This is why you have to overbuild your seawalls, your concrete, and your steel. And we even have 2 streets here that are collapsing from sinkholes, just like Brandon and a few other parts of Gibson. So that's a big issue here. And this place is being overbuilt for that reason. Now I can repair my seawall by pouring more concrete and it won't get hurt. This patio is almost 1 foot thick, and the steel is sufficient. This lanai right over here was replaced 2 years ago. It was completely torn off the building. Skipped one house, the next one that was torn off, replaced, and 2 of them down here, and the next 2 lakes. When Hurricane Charlie came through, it took out about 5 or 10 of them. So this is what the county is all concerned about, holding up and the wind rate. So hopefully people will want to go to this in the future, and that'll help All Steel as well. Henry might lose his roof, but I don't think the steel is going to go anywhere. They were also asking about the uplift on the concrete that he did on these bolts here, and the strength of the concrete to hold the bolts, because the hurricane's going to pull up, and all this was signed off and it's certified.